Solving polynomial equations. A polynomial is an algebraic expression of the form an x to the n plus an minus 1 x to the n minus 1, etc., plus a1x plus a0, where the ai's are called coefficients of the polynomial. The largest exponent of x is the degree of the polynomial. A polynomial equation of degree n is one that has the form an x to the n plus lower order terms, where a sub n is non-zero. So for example, 5x minus 1 is a degree 1 polynomial, or a linear equation. 2x squared minus 5x minus 1 equals 0 is a polynomial equation of degree 2. 2x cubed minus 8y squared plus x plus 1 is a degree 3 polynomial equation, and 6x cubed minus 1 equals 0 is another degree 3 polynomial equation. To solve equations of the form ax plus b equals 0, begin by subtracting b from both sides, and then divide both sides by a. If we want to solve something of the form ax squared plus bx plus c equals 0, we factor the left, and then we set each factor equal to 0 and solve. So for example, 4x minus 12 equals 0. We're going to add 12 to both sides. On the left, we get negative 12 plus 12 is going to sum to 0. 0 plus 12 on the right adds to 12. So we end up with 4x equals 12. We can divide both sides by 4 here and get x is equal to 3. Similarly, if we want to solve 2x squared plus 5x minus 3 equals 0, we factor the left, 2x minus 1 times x plus 3, and set each of those factors equal to 0. So 2x minus 1 equals 0, and x plus 3 equals 0. In the first equation, if 2x minus 1 is equal to 0, then x is equal to a half. If x plus 3 is equal to 0, then x is negative 3. For example, solve for x. If x squared minus 6x plus 5 is equal to 0. Begin by factoring the left side. Two numbers that add to negative 6 and multiply to positive 5. In this case, negative 1 and negative 5. So we get x minus 5 times x minus 1 equals 0. And so if x minus 5 is equal to 0, x has to be 5. If x minus 1 is equal to 0, x is equal to 1. So the solutions here for x squared minus 6x plus 5 is equal to 0 are 5 and 1. Another example, x squared plus 2x minus 15 equals 0. Two numbers that multiply to negative 15 but add to 2 are negative 5 and positive 5 and negative 3. So x plus 5 times x minus 3 has to equal 0. If x plus 5 is equal to 0, then x is negative 5. If x minus 3 is equal to 0, we have x is equal to 3. Another example, 6x squared plus 5x plus 1 is equal to 0. Again, we factor the left side. It factors to 3x plus 1 and 2x plus 1, and those are equal to 0. If 3x plus 1 is equal to 0, x has to be negative 1/3. If 2x plus 1 is equal to 0, then x is equal to negative 1/2. So our solutions are x equals negative 1/2 or negative 1/3. Example, x squared minus x is equal to 0. Here we can factor an x out of the left side to get x times x minus 1 is equal to 0. So either x is equal to 0 or x is equal to 1. Example, 16x squared minus 25 is equal to 0. We factor the left side to get 4x minus 5 times 4x plus 5 equals 0. If 4x minus 5 is equal to 0, x has to be positive 5 over 4. And if 4x plus 5 equal to 0, then x is negative 5 over 4. So the solution to this equation is x equals 5 over 4 or negative 5 over 4. Another example, x cubed minus 6x squared plus 5x is equal to 0. Here, this equation doesn't look like a degree 2 polynomial. However, if we factor an x out of the left side, we get x times x squared minus 6x plus 5, and the expression in the bracket is a degree 2 polynomial, which we can factor to x minus 5, x minus 1. So here we have three possible solutions: x equals 0, x equals 5, or x is equal to 1. Now, in the event that our quadratic ax squared plus bx plus c equals 0 is difficult to factor, then we can use the quadratic formula. Here, if ax squared plus bx plus c is equal to 0, then x has to be negative b plus or minus root of b squared minus 4ac divided by 2a. The term under the root sign is called the discriminant. If the discriminant is less than 0, then we have no real solutions. If the discriminant is greater than or equal to 0, then the equation has one or two real solutions. So for example, x squared minus 5x minus 12 equals 0 has solutions. Unfortunately, it's very difficult to find two numbers that multiply to 12 and add to 5. By the quadratic formula, we see that we take negative of negative 5 plus or minus negative 5 squared minus 4 times 1 times negative 12 divided by 2 times 1. That gives us 5 plus or minus 11 over 4. 5 plus 11 is 16, divided by 4 is 4. 5 minus 11 is going to be 6, negative 6, divided by 4, or negative 3/2. So the factors here, the solutions, are 4 and negative 3/2. Another example, x squared plus 2x minus 1 equals 0 has some solutions. Unfortunately, two numbers that multiply to negative 1 and add to 2 are difficult to find. So again, we use the quadratic formula. So x is going to be negative 2 plus or minus root of 2 squared minus 4 times 1 times negative 1 over 2 times 1, or negative 2 plus or minus 2 root 2 over 2. Negative 2 plus 2 root 2 over 2 is negative 1 plus root 2, and negative 2 minus 2 root 2 over 2 is negative 1 minus root 2. So those are our two answers. Let's solve 4x squared minus 12x plus 9 equals 0 for x. If you can't see how to factor this right away, go to the quadratic formula. Quadratic formula says negative of negative 12 plus or minus the root of negative 12 squared minus 4 times 9 over 2 times 4. That's equal to x. So doing a little bit of arithmetic, x is going to be 12 plus or minus root of 144 minus 144 over 8, or 12 plus minus root 0 over 8, or 12 over 8, which is 3/2. So the only solution here is x equals 3/2.